Okay, good afternoon, everyone, once again. So today we are going to go into a lot of hands-on, not just a bit of hands-on, on how to use your AI tools, the ones that are available and the ones you can build to improve your productivity. So, of course, this is our curriculum outline. We are in week 2 now. We are looking at AI-assisted development workflows. So we are going to first of all talk about how the AI directly impacts your productivity as a developer, essentially using tools like Copilot, Codium, and all the rest, ChatGPT and all of those to write code. I don't want to say I really encourage people to don't um I'll talk about that, right? But don't delegate your brain to an AI, right? You should match the AI. It becomes a friend, a pair programmer, a tool, right? And we'll talk about some of the reasons for that. So while we will make the best of these tools, but we should always be in control and we should always know and understand what we are doing. So we are going to talk about that. In this week's uh, we are focusing on AI assisted development workflows, right? So we're going to start off by looking at prompt engineering. Like I said, for the record, I don't like that terminology, but that's what the world is using. So I have to be, I have to put it here so that for the sake of communication, everyone understands. When I say I prefer to call it prompting, and in most places, you see me calling it prompting, not prompt engineering, because I already kind of spoke about that earlier, that when we say engineering has a lot. Some of us, we spend 5 years studying engineering, and then something that you are just breaking things down and somebody's calling that. But anyway, that's me just expressing myself. So we're going to look at prompt engineering, basics, and what we call prompt chaining techniques. We're going to talk about the approaches that you would use to improve your power, your prompting superpower for different tasks, but specifically for coding task and documentation task. Then we will look at some of the tools that we can use. Copilot, which requires a subscription. So I may not necessarily use Copilot, even though I do have a Copilot subscription. And when I do some of the demos, it will be very useful. But I understand that there are a bunch of people that may not have access to it. So we will also use Codium, which is a free open source. It's an extension that you can put in VS Code as well. We'll use ChatGPT. Cursor AI is an entire IDE that is built on top of VS Code, you know, IDE infrastructure, if I may use that terminology, but with fully built AI first LLMs. So Cursor is really powerful that way. So we'll look at that. I don't have a Cursor instance, but we can go try it out. Then we'll also look at how we can use AI for refactoring code bases, generating test coverage, doc strings. So this is where you kind of time stain yourself. For me, I have gotten to a point in my programming career where I spend 10% of my time writing code, the functionality, and I spent almost 90% writing test coverage. And it was really like, what's this all about? You understand? Because you can easily use a framework, to pull together anything, and just write your business logic. And within 2 or 3 days, you have written the feature. But to write a test coverage is another problem. So I've always asked myself, I needed, and that was before LLMs came in. Like, how can we multiply? Because test coverage is crazy, but we need to test driven development is best practice. You don't want to write code without test coverage. Test coverage is like the insurance, the peace of mind that you give yourself, that no matter what happens, right, you have a very high level of confidence that your app, your software is well built. So this is one of the really good areas that you can use AI to take stress away from yourself as a developer. Test coverage. and we will look at how you can do that. By the way, even the test coverage, when you're generating it, you're not just going to out tell the thing, generate test coverage for me, because you also know the things that you want to test, the scenarios. Documentation is another thing, you know, refactoring, right? Debugging, API generation. So these are all some of the things. Then later on Thursday or thereabout, we will do a mini project. This is a project sorry, on Friday. This is a project I really have also. Right now, in my current role, I do a lot of PR reviews and I spend so much time, reviewing PRs. I can't even write code anymore because I spend almost all the time reviewing PRs. So I've always wondered, can't I automate PR review processes? Like some of the basic things that I look for in a PR. Why don't I codify it and use an LLM? Interestingly enough, Copilot, GitHub has that, but you have to have a Copilot. No, not just you that has to have a Copilot subscription. The person that is submitting the PR has to have a Copilot subscription for that to be available. So that's not very helpful, if you are building with others and those people don't have Copilot subscription. So what happens is that you don't leverage from it. So anyway, that's what we'll look at today. So for us to understand this thing that we call prompt engineering or prompting, we need to first of all understand what is a large language model. Because essentially everything is based on this thing we call a large language model. So we talked about it a little bit last week, but I'm going to delve a bit deeper. So a large language model is an AI system, is trained on a large amount of text data, is built using neural networks. We'll look at that. That's what we have on the right side of this slide. But the main thing is that you have a huge corpus of data, right? Books, code, web pages, articles, as much as these big companies have been able to scrape from the internet and from other sources that are even offline, all of this information is being pushed to train large models that when you talk of parameters, billions of parameters or tens of billions of parameters, that's the size of these models. If you actually go to Hugging Face or Open Router like we did last week, and you go check out the size of some of these, you see, billions. That's the size of these things. So when these things are trained, because of the size of the number of parameters, that means they basically look at it this way. The number of parameters in a model is a measure of the capacity of that model, how much information or knowledge it can extract and store. The larger a model, the more information it can extract, store, and organize. So that's why they keep going to bigger and bigger models. A small model cannot store as much information. It's very logical because that's really what it is. So these models have been trained on a lot of data. So they are basically what we call a language model. But here's the thing, right? These models are not magical intelligences. They're actually not intelligent. That's why we're calling it artificial intelligence. They appear to be intelligent, right? They behave in an intelligent manner. They exhibit all of the traits that you would attribute to intelligence. And the reason that they are able to do that is because they have been trained to be able to predict. It's basically prediction. They're able to predict the next token in a sequence of tokens. They're able to predict the next word in a sequence, or even if you just start with a word, right, it will predict the next word. That's what it is. And we can do a bit of experiments. In fact, let me just do a little bit of experiment here, right? I'm going to do a little bit of experiment. I'm going to start off a Jupyter notebook, right? And I'm going to, for the sake of speed, I'm going to just pull in one of the things that I did last week, where we were able to call an API, right? So I'm just going to call an API. I think I have one that I wrote. Let me just look for it quickly. So if you give any of these LLMs a single word, right, it will come up with the next word. But which word will it come up with? That's the interesting thing. Which word will they come up with? Um, so let me pull this up. I have an open router key. This is this is code I'd already written last week. I think we saw when I wrote this. So I have an AI class. Um, so this is an AI client. Anybody can write, it's not hard. And then um, so while that one is building up, I now add, let me post this. So this is my open router. I shouldn't be showing this on the call anyway, but let me take it out and load it from an environment variable, which I have the code for it. So um, I'm going to revoke this anyway, so it's not a big problem. So I have a .m file. So I'm going to load this from the .m file, and I can then put .m file here, open router key. Okay. So I will also bring in a helper function, which I had previously written, that um, allows me to load any key. Um, yes, get API key. Yeah, well, let me just do this so it's faster. So I'm just doing all this because I really want to try out something. I want to show us this whole idea that uh, an LLM just predicts sequences. You're asking me maybe now, you're asking yourself, why don't I just go to ChatGPT and type in a single prompt? The reason is ChatGPT has a lot of system prompts, so the behavior is going to be modified. I don't want the behavior to be modified, right? I want it to just no context, no modification of behavior. The current ones that we have, you will see that there's something going on behind underneath it. So it's not really only your prompt only exactly that's getting sent, right? Okay, so I'm not going to use a user prompt. Um, so I'll just type a prompt. Let's say hello, right? So this is simple. Um, and then it will give me sorry, I forgot this get API key, so I need to get the API key. Okay. So I'm missing something. Okay, imports. JSON and requests. Okay, we'll try again. So I just sent a prompt, hello. There are so many different things it can give me, right? This is a message. Hello, what can I help with today? So, okay, now maybe I will want to print only the response. So only the content of the response. I don't want to um response, the choices, 0. Okay. So, but anyway, this is the response. I don't want to waste time trying to extract this. Hello, what can I help you with today? Whether you have questions, need information, want to chat. This is the response. Now, if I run this and just do some word that doesn't, is very ambiguous, THE, right? It's going to pick up the next. So essentially what it's doing is, oh yeah, this is, let's just leave this as it is. So it's going to pick up and try to predict the next word. That's what it does. And then when it predicts the next word, it takes those two words and tries to predict the third word. And when it takes the three words, it keeps going, right? So we are going to look at the mechanism behind it. The only thing is that it's trained with so much information that if you give it a nice long string of words, right, it begins to make a the more words you give to it, the better its prediction. Because if you start with a THE, there are millions of different sequences of words that can start with THE. So it doesn't know which one it will give you. And that's why it's giving me this answer. It looks like your message was cut off. This is actually a system prompt. Because if it was a raw model, the raw model would still try to prepare something and give to me, right? Or maybe it has been trained to be able to do this. But anyway, this is what um, is the underlying thing behind AI. This is basically what it is, right? The large language model, it predicts the next most likely word or token, given all the previous ones. But it does it at massive scale. And it has a deep contextual understanding. That deep contextual understanding comes from being trained on so much data. It begins to pull out things that make sense, concepts that make sense. Internally, there's actually representation of knowledge. There's actually representation of knowledge based on aggregation of all of the data you have given it and you have trained it. That's what a large language model is. And we're going to talk about how this affects your use of these models, right? Now, just for the sake of completeness, this is an explanation of the ideas or the concept behind a large language model. The architecture is a neural network. It's based on what we call a transformer architecture. Transformer architecture was initiated, or the people that pioneered the architecture work for Google, or they worked for Google. A paper was written in 2017 about it. That paper was called Attention is All You Need. It uses a concept called attention mechanism, which if you do machine learning, you will understand what that means. But what it means is that the attention allows you to map a word to other words so that you can map the relationships between lots of words. It's kind of a matrix, right, that maps relationships between words in a long sentence from one word to the other. So that allows, words that are more related will have a stronger mapping. Words that are not so related will not have a very strong mapping. It will be a weak link. So that way, from a word, you have a meaning. But if another word comes next to it, that first word, the meaning changes and all of that. So we're not really going to go into all of that, but it's just good to know. A token is a small unit that you break long text or sentences or words or paragraphs, the entire body of information. You break into small units, small, tiny, this kind of think of it like a molecule in the context of natural language processing. So these units can be a word or it can be a group of words, but typically they're usually words, right? But it won't be smaller than a word. So for example, you cannot have half of a word being a token, right? So this token is what is converted into a digitized What I mean by digitize now is a number, what we call a vector, and embedding. We talked about embeddings before, and we're going to talk about embeddings in future because we are going to use embeddings in improving performance of LLMs, right? So we need to understand what that embedding is. So you take a token, right? You convert it, you train them. The network already has a meaning that it attaches to that word. That meaning or that understanding of that word is what we call an embedding. That's not a very good definition though, but an embedding is like a digital equivalent. It's basically a vector of numbers. A vector is a list. Think of it like an array that has floating point numbers or decimal numbers, right? That array of numbers representing that word, it has a meaning and it's called embedding. So for you to get an embedding, you need to first of all tokenize the words. When you tokenize, then the next step would have been, embedding and so on. The embedding is what is then used in training the model. So the model will be trained with all of this. So it learns how to predict. It can predict the next token because it kind of statistically sees that anytime you have THE, these are the words that follow it. Anytime you have THE, the and MAN, the man, it, from that data you've given it, it kind of gets an idea of what most likely always comes after this sequence of words. And that's how it learns. So over billions of examples, you adjust the internal parameters. The parameters are the things that store the knowledge, right? What we call weights or biases, generically or generally we call it parameters. Now, one thing that's very important is what we call the context window. For large language models, for natural language processing, that's very important. The context window is the maximum size or length of text that the model can consume at once and see at once, because it's not actually seeing those words one by one. It's seeing all of them at once, right? It has to see all of them at once, even though it's supposed to be what we call a recurrent neural network, but even that those have what we call a context window. So a context window is the maximum length or amount of text or amount of tokens, technically is the number of tokens, the maximum number of tokens that this LLM can consume, can see at a go. And it has to see all of them at once to be able to make meaning and predict the next token. That size is a limitation, because what it means is that anything outside of this context window, it's like it doesn't have any memory of it, right? So if your context window is 300 words and you type a prompt that is longer than 300 words, right? If it chops off the first one and takes only the last 300 words, I'm just using words as it actually should be 300 tokens, but let's just, for the sake of the explanation, right, go with words. If you chop it off, it only takes the last 300 words. Any other thing that you give to it as part of the prompt, it doesn't know about it. You understand? It's just like, again, I'm sorry for, I always talk about the old grammars, but it's just like that old grammar, like you told her something 5 minutes ago and then you came and said something else concerning that thing now, and she has forgotten what you told her 5 minutes ago, right? And she's asking, when did we discuss that one? Think of it that way. The context is not there anymore. That's why it's called a context window. So the context window is the size of how much context you can put into the LLM. It is very important, and we're going to talk about that later on. So there's limitations, and the bigger the model, the larger the context window, the smaller the model, and so on. Then parameters, yes, like I said, the parameters, that is actually the memory, that's actually the knowledge. That's how the knowledge is stored. The parameter is basically billions of numbers, floating point numbers, whether it's single precision or double or half precision or any of these other ones, but floating point numbers that are adjusted as the model is learning. By the time the model has learned, those numbers have to stay unchanged. Once you change any of those numbers, you have changed the knowledge of a model. So that is how the model understands and generates the text. And it's not just large language models, any other kind of neural network or any other kind of machine learning model. Basically, you store the knowledge in the parameters. So what is the LLM learning? The LLM is not learning exact facts. They are learning grammar and syntax. That's why it's called a language model. And what you are giving it, the data you're giving to training is language data. So it's going to first of all learn about language, grammar and syntax, and it's going to understand grammar and syntax. It's going to understand when you should have past tense and present, when you should have plural and singular. It will understand that first. When it has understood that, the next level or layer would be logical relationships between the concepts that you have given it to learn. Then it will understand, it will learn the semantic patterns. Then it will learn what we call task structures. So for example, how to write an essay or how to define a Python function. It will understand that a how to do this means this. It's not really understanding. I'm sorry for using that term, understand. It's not correct. It learns, and it learns to predict the next thing. This is, you have to understand it this way, right? Then it reasoning heuristics, right? From examples seen during training. So, and an LLM doesn't know like a human being does. It doesn't understand like a human being does. Rather, it recognizes patterns and it predicts what is the next thing that should follow based on the previous pattern that you have given it. And how, something that's consistent with that. So when you type a prompt, what is actually happening is that the LLM is trying to mimic how a human being would have responded. Think of it that way. It's actually not responding to you. It is rather giving you a response, trying to predict or mimic how a human being, if you give it that same question or prompt, how a human being would have responded to you. Or maybe not a human being, but based on the training data, how it would have responded to you. That's what large language models do. They're essentially predicting and they're mimicking. This is very important to understand. So when you understand this, then you understand that you can get the best out of it. So there are 6 things that you will first of all realize once you have gotten this understanding, right? First of all, you have to design your prompts to align with the strength of the LLM and to avoid the weaknesses of the LLM. The first thing is that the LLM is predicting patterns. It's not telling you the truth. It doesn't know anything about truth. It doesn't know the concept of the truth. It only knows that when this, in its training data, when this information was coming in, this is what was following, right? So if you train it on falsehood, it will give you the same falsehood that you trained it on. If you train it on truth, it will give you, whatever you train it on is what it will give. This is very important. LLMs are probabilistic predictors. They generate plausible responses, not necessarily correct ones. One thing with LLMs, it must give you an answer because it is trained on data. It must give you an answer, right? And it doesn't really matter whether that answer is true or not, even though we now have layers on top, and we'll talk about that to ensure that. And that's what you as a developer need to know. You are more than a user of an LLM. You are also a developer, right? So you need to know the weaknesses. And if an LLM tells you, no, I don't know the answer to this, it is probably because somebody tuned it that way. Okay. So with this, you understand that if you want to write a prompt, you have to give it as much information as possible to narrow potentially, the different options it has to contend with. So for example, instead of saying, what is the best sorting algorithm, right? A better option will be, what is the best sorting algorithm? Is now you asking it for an opinion, which it doesn't have. LLMs don't have opinions, right? If LLM gives you something that sounds like an opinion, it is basically kind of, doing something that it thinks somebody else would have done. And it's not really its opinion. It is gathered from, training data and trying to generalize. So instead of that, you're always safer asking LLMs to give you factual information based on its training data, based on its search of the internet. Some of them can search the internet now and all of that. So instead of saying what is the best sorting algorithm, you give it a prompt that says list the common sorting algorithms, their time complexity, and when each is preferred, and then cite your reasoning. What have you done? The difference between the first approach and the second approach is that the second approach, you're asking it to give you facts. Then you make your own judgment based on the facts that it gives you, rather than you asking it for an opinion. And if you ask it for an opinion like this first one, it will actually give you an opinion, because there are people on the internet that keep saying, oh, the best, like, okay, if you ask it, what's the best programming language, for example, it will actually go and look at arguments between PHP people and Python people and so on, and whatever. I don't know what it comes up with. I would like to test that out and see what I get. Okay. So this kind of prompt, when you understand it predicts pattern, not truth, you seek for facts, you seek for information. You can also ask it to give you more information to help you make your decision. At the end of the day, the most important thing is that you, the human being, are the one making the decision, not the LLM. And that's why I say you cannot outsource your brain to an AI, because the AI is not superior to your brain. Your brain is actually superior to the AI. The only thing is that the AI has access to vast amounts of information and knowledge that you do not have. The AI has been trained on a lot of stuff on the internet. You have not been trained on any of that, right? So what you do is you use the AI to pull that information to you in a summarized form that you can use your brain to approach and make your decision. It also means that you have to have knowledge. You cannot judge if you don't have knowledge. I've always said it, you have to be as good as the AI in your area of specialty. You have to be good. You have to be better. So even when AI is doing stuff for you, you need to know how it did it. You need to be able to review what an AI has done. So that's the first one. The second thing is, when you understand this, you learn to give context. That means you have to give more information. You have to give all the information or as much information as needed by the AI to give you a very good answer. If you do not, if you leave an open-ended prompt or question like write a fast API app, you did not tell it what the first API app will do. You did not tell it how many endpoints it will have. You did not even say anything. It will just generate randomly. And once it starts generating randomly, at some point, the randomness the randomness will kind of coagulate, if I may use that English, right? Because it has now gotten enough tokens to point in a very specific direction, but that specific direction is not the direction that you wanted. So you have to define the direction that the LLM is going to make its predictions or pull in, the information by having enough context, right? So the more relevant and structured your context is, the better. So instead of a bad prompt like write a fast API app, you give a better prompt. You are a senior backend engineer. That's context. Write a fast API app with one get and one post endpoint for managing tasks. Use Pydantic for validation and include example requests. It will now generate this app for you really fast, right? But one thing you also need to understand is that LLMs are non-deterministic, right? What I mean by non-deterministic is if you give it this same prompt 3 times or 5 times, it will likely give you 5 different fast API apps. Even though they are trying to make them more deterministic now. Deterministic means I should always give the same answer, if the same question is asked. Even though humans are not actually deterministic either. If I ask you a question, the way you answer me would be different, but the content of the answer would probably likely be the same each time. Okay. So that's the second thing. Um, By specifying the role, task, and format, you shape the statistical space. That's what basically that means. You narrow down the options that the LLM should be choosing from when it's trying to predict to be in a space that you want. That's what we mean by statistical space. The third thing you understand is exploit the model strength. strength in imitation. It knows how to imitate very well. LLMs are excellent. You give it something, it will follow exactly that thing, right? They'll produce output that follows a style. So it's better for you when you say write a function to do this. You can say following this style, right? It will give you, and you can even say, I want you to analyze this data and give me these answers, follow this format. It is going to follow it faithfully. So that's one of the strengths which you can use. Fourth, manage a context window. We just talked about context window. So you need to know the context window, the limit of the LLM, whichever model you are using. By the way, different models have different sizes of context window. And you find that the bigger ones, at some point you can have a context window that is a whole, file, like a whole book, right? It might be more costly. So it's very important to understand that. So let's assume an LLM has a 16K token context window. That means that I don't know what 16K tokens would translate into, but let's assume, just for the sake of simplicity of explanation, each token maps to one word. That means you can only put 16,000 word prompt into this LLM. So what does that mean? If you wanted it to summarize, or let's say you want it to refactor code base for you, you cannot give it more than 16,000 word code base. If you give it that, it will cut it off. I don't know if any of you have tried, like you wanted ChatGPT to analyze. I do that a lot. I give it code and I tell it, analyze it for me. You analyze it, after some time, the thing will start talking rubbish. It will not be associated with what you gave it at all. What has happened is that you have exceeded the context window. So it doesn't have all the previous, information. So it more or less just starts from scratch. And it's going to give you rubbish. It will not be like, why? I've done that. I can even show you a conversation I had with ChatGPT. And we're talking about so many things. And at some point, it just said, this thing you are telling me, I don't understand what you're telling. I said, wait, this is just something that we just discussed now. It was out of the context window. So if you want to use it to do a task, for example, you want to refactor a code base, and I'm going to talk about that shortly, you need to ask yourself, what's the context size? Okay, how do I summarize my entire code base or the files that I want to refactor into this context size, right? And if it is code, you cannot summarize code now. So maybe you figure out. But there are a few apps, by the way. I was looking for one of them, and I'll show you. If I can't find it during this course, I'll share it on the channel, where it 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 compresses entire code bases, entire repo into a single file. It removes unnecessary stuff like white space and all of that. And it then gives some prompts. So you can take that file, upload it into an LLM. I can tell it, you can even search and say, okay, I want to call this method. What is the argument that I can use to call this method? Okay. So but in all of that, you need to be very aware and you need to be careful about the size of the context window. Okay, Kinika, go ahead. Your hand is up.
Okay, sir. Yes, sir. Talking about context, I've noticed this pattern, and some of my colleagues too have noticed the same pattern. At that point when ChatGPT starts saying off point, like they start talking off point, I'll notice that if I paste the same question on a fresh chat, same ChatGPT, but a fresh chat, it starts answering like somebody that is okay. I don't know how to
Yeah.
put that. Like it starts, and I want to understand the context in this
Yes,
scenario. Is the
I can
context
explain
based
that.
on the whole chat GPT? Okay.
Yes.
I wanted to ask if it's based on the whole chat GPT or that particular chat.
Yes. So let me explain that. When you open a new chat with ChatGPT, in old days, let me say old day, like maybe last year or something, it actually starts from zero, like no context, no memory, no history of your previous discussion. You start a chat, so you have to put in all the context and you build it up, right? ChatGPT has a really large context window. So what is actually happening behind the scenes is that the developers, each chat that you type, it will still send, it will concatenate all of the previous chat you have, done into a chat history and puts it as part of the prompt. Then the one you just typed recently, it adds it. So it basically puts all your chat into a list and sends it as the history of the prompt. It concatenates it. So that gives ChatGPT the context that you people have been discussing these things since, right? So this last one, it will be able to answer. Okay. But the issue now is that when that your history, that the app, by the way, for your information, the user interface I use for ChatGPT is just a front end app. That's not ChatGPT. That's just a front end app, which any of you here can write. And we will do that as an exercise. It's very easy. But the thing is this, right? When the chat becomes very long, the history that you have concatenated becomes it at some point it exceeds the context window. At that point, what happens is that the first few, whatever first, in fact, the last piece of the history that fits the context window is what goes to ChatGPT. Every other thing before then is lost, doesn't go in. And that's where ChatGPT forgets everything, right? If you open a new chat, then you're starting a new one again. If you post, you cannot post the whole history of what you typed, right? So you're probably going to pick one or two that makes sense and you post. It starts afresh, but it doesn't lose that. It has a context, right? Even though recently they have what we call memory now with all these LLMs, which is a way to store previous history of conversations. So you even find, like I've seen that with ChatGPT, when you are chatting, before it used to be that if you open a new window, it starts afresh. It will not remember what you chatted in a previous window. But now it still remembers all of the previous chats that you had in previous windows. So they are constantly improving it. They are developers like us. So they are seeing, pain points, UX issues, and they're improving it in different ways. So that's the answer to that. So this is very important for you to understand context window. Okay. The other thing is when you have, okay, so now that we recognize that context window is a limitation, if you give it a very long task, there are two things, right? Apart from even the context window, which limits the length of, by the way, when you give it a task, the data that you want it to analyze is also going to be part of the prompt, right? So if you want it to refactor a file, if that file has, 15,000 lines of code, you have 3 or 4 files, altogether is maybe 20,000 lines of code, and the context window is 16K tokens, right? It will not fit. So it will not be able to do a proper job of refactoring those that folder or that code base or whatever, right? So, but that's one problem. This problem is now talking about a problem that is so complex, it cannot do it at a go. So what you do, you split that problem into smaller steps. It's just like a human being. It's the same thing. This is where you as a programmer, you become, you hold sway, because as a programmer, you already know how to split large stuff into smaller steps. You do the same thing. You know, you take, so for example, this is an example. You split down into steps. Each of those steps is what we call, or the entire combination of steps is what we call a chain. A chain is a sequence of prompts that you send one after the other to the LLM. You send the first one, it gives you results. You take the results of that first um, prompt, you add the next prompt in the chain, and you send it back to the LLM. It processes it and gives you a response. The response from that one, again, you add it to the next prompt, and so on. So instead of saying something like, um, you know, write a code file for me and refactor it, or instead of something like refactor this code base, which would be really complex for the LLM to do, refactor this code base. You split it up. First, step one, summarize this code file. So you give it the code file. You ask it to summarize, especially if the code file is really big, right? Summarize this code file. It summarizes it. Two, Least possible improvement, that's a new prompt, a new step in the chain. Then third, apply these improvements and explain what changed. It will now generate new code for you, right? And do the refactoring. So instead of you saying refactor this file, you split that task into what would refactoring entail. It's going to give you much better results because it's now handling smaller tasks, just like any human being. You the amount of information, amount of things that you can hold in your head. For you, the things you can hold in your head, that's your context window too. Human beings also have context windows, you know. So that becomes very important. This is more effective, right? Because when you understand that LLMs are doing token by token, it's easier for you to give it tasks that are related at once, right? Rather than giving it a a huge, very amorphous task that contains or involves a lot of sub tasks or sub steps or sub activities. The first thing you'll be asking is for it to even be able to understand which one is which sub activity. That's additional understanding, that you're demanding from LLM. But you, as an engineer, you understand those subtasks better. So break it down and give the LLM as a chain, as a sequence of steps, and it will handle that. Then the last thing is what we call temperature. Temperature, most people that do chat, they don't even know about temperature, but temperature is an additional variable you introduce into your prompt to randomize the results that the LLM gives you so that it won't always be the same all the time. It will explore other possibilities when it is generating these responses for you, right? So, but typically, if the temperature is too high, it begins to generate a lot of nonsense because it's even trying things that don't make sense, right? But if you limit your temperature to a small range, like this 0.0 to 0.3, by the way, I think the highest temperature typically is 1 because it's in the range of 0 to 1. So 0.0 to 0.3 makes it deterministic. Deterministic means with a temperature of 0, it will always give you the same, it will be super deterministic. Deterministic means for the same question, it will always give you the same answer, right? um, as you increase the temperature, it becomes more and more non-deterministic. So it begins to try other options, but it still stays within options that make sense, that are good, right? So that's why it says deterministic and it's good for coding. But when you go too high from 0.7 to 1, it begins to become very random. This is not good for coding. Because with coding, you want something that is very stable. You always want responses that are, that make sense. But if you want to use it in creative kind of context, you're not actually going to use a code, but just to give you ideas. You can go for higher temperature. Like it says, it's good for brainstorming. So this is something you can introduce into your prompt as you are building, your tool, right? You are using prompts. You need to be able to say, okay, for this one, do I increase or not? Temperature doesn't mean heat in this case. Temperature means variability. It means randomness. Because if you actually study thermodynamics, temperature comes as a result of randomness of movement of molecules. That's where the whole meaning came from. So in this case, it actually means the randomness or variability of the output that comes from the LLM or anything, any machine learning model specifically. Even for any other thing, neural networks and so on, we use temperature a lot. That's the terminology, right? It has nothing. It's not heat. Yes, Ngozi, go ahead.
Yes, sir. Please, how do we use this temperature? Do we start imputing those figures while chatting with the
No, you
LLM?
you will not use temperature when you are chatting. You're using temperature as a developer, as a programmer. When you are sending, so let me show you this, right? When you are sending the prompt to the backend, right? In this place, there is payload. This payload, there is also a parameter called temperature, which you will send, and you can send any value, right? This is how you send it. So temperature is not available to a user, it's available to developer, but as a developer, you can also make it possible for the user to set the temperature, and then whatever the user chose or set, right? You can then send it. So this is what it is. As you are specifying the model, the message, you can also specify the temperature. That's how you send it. I don't know if ChatGPT gives you opportunity to choose temperature. That's a UI thing, right? So if they choose to add it, yeah, I've never tried it. So maybe I would say um, you guys can try it and see if it's even possible if they have made that available, but probably not. Okay. All right. So that's basically what LLMs are. So this is a summary of what I've said. The insight from LLMs, let me summarize. First of all, we know that LLMs predict the next token. So for you to be able to get a very good response from it, you have to give it clear structure, examples, clear context. It has to be very clear what you want it to do. It has a limited context window. Okay. So if you give it too much, if what you're asking it to do is too much, it will not get everything. And so what it gives you may not be a very good answer. The output is probabilistic, right? So whenever I give you an output, you should always ask it to explain itself. And this is very important for a developer because if it tells you, okay, this is the algorithm I use to do this, you need to ask yourself, what is the basis of this algorithm? Why? You need to understand because at the end of the day, the human being has to be the final sign off on what you cannot just copy what an LLM gives you and throw it out. You can't just share it with people. You have to do due diligence. So what that means is you have to know, you have to have knowledge of what the LLM is trying to do as well. It's sensitive to roles. So and task framing. So you need to always include the role. I am a senior developer, I'm a junior developer, I'm a product manager, and this is that, that. You need to give it, objective also, and then you give it a format. Send your output in this format. It imitates patterns very well. So if you give it a sample format, that's always the best practice, a good way of doing it because it will follow that your sample. It doesn't plan the steps. So do not give it ambiguous tasks that are multi-step or involve a lot of different things to be done one after the other. It will mess up. The best way is if your task is like that, you have to break it down for it and use prompt chaining. So we are going to talk about prompt. Most of the things here are more or less, what I have already said. So what is prompt engineering? The prompt engineering is the practice of designing and refining inputs, which is the prompt that you give to an AI to guide it so it gives you accurate, relevant, and high quality output. It's something you have to pay attention to, even though I still disagree with the word engineering because yes, a lot of stuff goes into it, but I don't think it's enough. Hey, it's not, you don't use 7 years or 5 years like somebody I saw here. You don't use 7 years to learn how to write prompts. So I don't understand. Anyway, so a prompt, right, for an AI or an LLM, think of it as a specification document. So from an engineering standpoint, yes, it's a specification document. You are telling it what to do, and you're giving the very clear specification. The more specific, that's why it's called specification. The more specific your specification is, the better the result that it gives to you. But if your specification is not very clear, what happens is it can just give you whatever it likes. And then you'll be wondering, this is not what I wanted, right? So this is the structure of an effective prompt. Number one, you must specify role or context, like we've already said. Define the persona or task type. You're a senior Python developer, you're a senior JavaScript, you are doing this, give it a role, give it a task and describe that task exactly what you want. Write a function that calculates compound interest, you know, constraints, they must be constraints because it's not open-ended. Use only this library or use only this package or use only this, right? It's always good to give you an output format as well, if possible. Return the result as a function or as a tuple or, use object-oriented, that kind of stuff, right? And if possible, you can give it examples and say, let your example follow this For example, this is that, this is that. That helps you to get a very good quality response from your prompt. Then for a developer as well, these are the additional tips. Be specific. So avoid vague requests, right? If you have code that you are trying to understand, instead of saying explain this code, right? Give it more information. Explain what this section of code does and why does it do it this way. Okay. Then you set the rule. That's very well we've already said. Okay. Iterate. So this is another thing that people don't understand. Your first prompt may not give you the best output. You can do a follow-up, right? And say, okay, this answer you gave me is not in this format. Can you redo it in this format? Or exclude this from this answer. I can see that you're adding this other stuff, you know. For example, if you are adding you know, speed testing, remove it, that kind of thing. You can fine tune, iterate, tweak your words to improve, ask for, a new answer, and so on. Decompose tasks, that's what we've already talked about. Okay. So that it's able to follow. Even when it is not a prompt chain, like you are actually putting everything in a single prompt, right? Still is a good idea to give it step by step in that same one prompt. As you can see here, first list functions in the code, then write docstrines for each. Okay. Then use delimiters. Delimiters are very important because these models are trained with delimiters, and those delimiters, because they are trained with delimiters, comma, brackets, even the delimiter that we use for code, right? Or quotes. It's trained with all this data. So it has come to understand that these things have meaning. So when you add them in your own prompt, it already switches it into a context where it understands what you are doing. So for example, when you use code like the triple tick, I always use triple tick. So let me show you an example. If I'm doing a prompt with ChatGPT, for example, you will see that whenever I want to post a code snippet, I use a triple tick, which is what we use in Markdown. So let me show you in Markdown language. There is this thing. If you go to Colab, right? If I open a text, right? This is Markdown, the text block. You use 3 ticks and 3 ticks for code block, right? This is a code block. If you look at this basically is going to be as a code block. In fact, the interesting thing is that this one will even add some like on GitHub, it will even add that thing that you can use to copy it, right? That's a code block. This is not a code block. By the way, go and study Markdown. We use a lot these days, so it's good to study this. This is not a code block. So you see there, you can even have a heading. A heading is like hash. This is a heading 1. Right? 2 hashes is heading 2, right? And so on, 3 hashes is heading 3. And so on. So you see all of that coming through and you will see the preview on the right. So this is Markdown, right? Interesting thing is if you want to have a specific, I'm just kind of digressing into Markdown. If I want a specific programming language, I can specify the language here and it will now, mark down as you now see it shows it does the color coding. If it is JavaScript, you could also just do that. So this is Markdown. So if you use these 3 ticks, right, already you are giving a context that this is actually a code block. So it actually matters. It helps in the understanding of the LLM. Okay, so now let's So this is some of the tips for you as a programmer. Now let's move quickly to prompt chaining. So I already talked about prompt chaining. Prompt chaining is basically a practice where you link multiple prompts together. So the output from one prompt, you put it as an input to the next, and you add it the next prompt, right? It's useful for multi-step reasoning, automation, where the task is so complex. The LLM will not be able to handle it if you send it as a single prompt. So a good example is you want to do code generation. So the first prompt will be write a Python function that validates email addresses. Then the second prompt, once the response from that one comes, the second prompt will be add a detailed doc string to this function. Then the third prompt would be generate PyTest tests for the above function. And then the fourth prompt would be summarize this module in 3 bullet points, right? Now, you could do this manually, and there are even graphical UIs that allow you to do prompt chaining and just try out because when you're designing your prompt, especially for a task, you may say, okay, let me even test it out on some data and see how well it works for me. If it works very well, good. Because you don't want to just um, use use your what you think, use your mind. Oh, this is what I think. This is how I think I should break it down. And then you plug it into your code. And then when you run that prompt chain, it doesn't work, right? Or it doesn't give you so you want to test the prompt just like you test your test, you write any code, you want to test it first. So maybe you want to test your prompt chain first before you put it in your product, or you write your code around it. Okay. So um there are things that allow you to automate the prompt chain as well. In fact, when you hear LangChain is basically a tool that you use for automating prompt chains, but it does a lot more than that as well. That's why it's called LangChain. So whenever you hear chain, right? So we have visual tools for prompt chaining, right? These are tools that you use to write the prompt. You chain them, then you test the prompt chain as you are prompting it. It has easy to use drag and drop interfaces. It's very useful for quick prototyping of prompts before you do the final implementation. And it also allows you to evaluate performance of different models. So there are some that like you can do a prompt chain and you choose which model, maybe Llama, you know, 0.2, right? And then you do the same prompt chain, you do another model, maybe GPT 3.5, and you run on both, right? And it will give you the response from those. So these are examples of visual tools. You have ChainForge, Prompt Chainer, Prompt Layer, Rivet. I actually opened ChainForge here. So um, this is how Forge looks like, right? You basically have a user interface. So it gives you a lot of stuff. First of all, you can add notes. The notes allow you to bring in text data, tabular data, items data, media, which is images, videos. Then you can also have a prompt note which will ask somebody for input, right? Then it has evaluators and processors. Then it has visualizers that can visualize the output. Then um, you add a node, then you can add a prompt node. So in this case, you have 3 nodes. You have a text field node, which allows me to put multiple um, inputs as text, right? Then I have a prompt node that allows me to put the prompt in here. So here I have a single prompt. This is a variable. So this variable refers to this, which we already called it books, right? That's the name of this text field. Okay. Then so the input from it is called book. You can see it's tied to this input. So you can also add others, right? You can add other variants and connect them. So um so when you add it, it's called book. So I now bring the book in as a variable here. So what now happens is that each of these text fields, it will iteratively, right, run the prompt and replace the book with this thing. So for example, it will run a prompt, what is the opening sentence of Pride and Prejudice by Jane Austen? That's the first one. It will send that prompt. So here you can see that we also added 2 prompt providers. So there are different prompt providers, OpenAI, all the GPTs here, O3 Mini, and all the rest, Claude, all the Claude Of course, you have to put in the API key for this to work. So all the Claude, then Gemini also has all of this. Then DeepSeek, right? Hugging Face, and so on. So you can add multiple prompt providers here, right? That's the benefit. So like here, two prompt providers will add a Falcon 7B and then this chat GPT. You can check the settings. Yeah, you can even tweak the settings, right? Frequency penalty, logic bias, presence penalty, and all of this. Okay, I'm not going to go through this in. So see that temperature we're talking about. So you can even add temperature here. I think this is 0.5 or 1. Sorry, this is 1. So you can go above 1 or below 1. So you put in all of this. GPT 3.5 Turbo, which we saw from last week that this is a free one that we can access. So yes, all right. So once you set up providers, what will happen is for each of these messages, it's going to send a prompt modified with this to each of these providers and give you the response. So you can then compare the responses. So this inspect node is a third node that you can use basically to see the result. So you see it has already been run, so you can even see this result. What is the opening sentence? So this is the first one, book Pride and Prejudice by Jane Austen. So the prompt that was sent is, what is the opening sentence of Pride and Prejudice by Jane Austen? It gives two answers. One is from Falcon 7B, which is this first provider. Second one is from ChatGPT. And you can see the results from those for that prompt. It's a truth universally acknowledged, blah, blah, blah. So this is just a good example. You have the next one, that's Pride and Prejudice. You have Crime and Punishment, which is the second input that you ask for. It also gives you the prompts from the two providers, right? And so on and so forth. So the beauty of this tool is that you can try different prompts, combine them. You can even chain the prompts. So like the result from this prompt, you can chain it into another prompt, right? And view the results from from that second prompt. And you can still use the same providers or add new providers. So this allows you to essentially try out so many different things and see if your prompts are good and what it gives you. So this is the benefit. There are other ones. There's another one called Rivet, which I think you can go check out as well. There are a bunch of them. I'm going to send links. So this is what the visual tools, these are visual tools. But as a developer, you're not just going to end with the visual tool. The visual tool is to help you prototype your prompting, to prototype your prompt chains, which you will need in order to be able to solve a bigger problem. After you have done that, you will still plug it into your code and then you will write the code. So we'll go into writing of the code on Friday, even though I would like to start with a few things, just to give us an idea. So this is a good example of a prompt chain. You first of all decompose a task into small steps. Then the first LLM call will process the initial input. The intermediate input comes back. You append it. You append that to the second prompt, right? And you still send it, and then it gives you a response. And you can just continue processing all the thing like that until you get your final output. So prompt chains are very, very powerful. That's why you have the whole lang chain and all of that. Okay, so for coding task, right? These are some of examples of um, how you can prompt things. And we're going to try some of these, right? I'm going to use Claude and we'll try a few things. So the first one, this is for writing functions, modules, or boilerplate. You're an expert Python developer. Write a fast API endpoint that accepts a JSON body with name and email and returns a greeting. Ensure you include input validation. See how this prompt is. It is very detailed. Well, not detailed, but at least it gives a lot of information. That's for code generation. So again, remember, let me say this very clearly because this is not a license for you to outsource your brain to AI, right? When it generates the code, you still need to look at it and you still need to clean it up. This is a tool to speed up your productivity. It's not to replace you. Once you start, doing that, when we say AI will replace people, yes, it will replace you, but you need to add value. And it is in this little ways that you begin to see your own place and your own value. The AI is a pair programmer or even a junior dev for you. If you're a senior dev like me, right? Then the AI becomes your junior dev that you give it task, it does for you, and you clean it up, you assemble it. So what does it do? It means that you are now thinking of higher level stuff. You're no more thinking about coding or programming or debugging. You are thinking of engineering the software. You're thinking of deployment. You're thinking of scaling. You're thinking of products. You are now thinking at product level, right? Because you know how to think at the coding level. You know how to think at the product level. I will talk about this maybe in a separate workshop about, the mindset of a software developer, right? The coder mindset, or the coder level, the programmer mindset or the programmer level, the developer mindset, right? Then the engineer mindset, right? Those are the four levels of thinking or four levels of, should I say, operating as a developer. Coders and coders have been replaced. If all you can do is a coder, you are gone. A coder is basically somebody who knows a particular programming language. Your own advantage is, oh, I know this language and you don't know it. So I'm the only one that can write. You are gone because AI can write any programming language. Programmer is the next level. What makes a programmer slightly ahead of a coder is that a programmer is not just, oh, give me the code, let me just translate it to this programming language and give it to you, which is what a coder is. But a programmer is, I write the code, I can debug it, I can make it work, I can fix it. It's the code becomes functional. I'm not just writing it, right? So what keeps you ahead is you can debug, you can troubleshoot, and you can integrate. But even these days, of course, AI, we are using AI for debugging stuff. So that one, they're coming close. So as far as I'm concerned, coders and programmers have already been replaced. So the only thing left for you as a human being is to be a developer and an engineer. A developer is, you build the code, you pull together. A developer is kind of like is a software engineer that is also a project manager, a product manager. You pull in all the different parts of the software development life cycle. You bring in the designer, you bring in the software tester, you bring in the DevOps and all of that. All of you work together. Yes, you are also writing the code as well, right? But you are looking at the product's entire life cycle. That's what a developer is. That's why it's called developer. You're actually developing a product. You're not just writing code. Then the highest level is software engineer. You're architecting the software. You are engineering the software. So you are talking about programming paradigms. You are is systems thinking. You are thinking of the entire software. What's the best way of building it? When we talk about things like reusability, packaging and, all of that, invention of, what do you call it? Anyway, that's not the subject for this. But what I'm just trying to tell you is that at this point right now, where we are in the world today, AI has taken over the coder's job and the developers, sorry, and the programmer's job. What is remaining is developer, because AI cannot do multitask. They cannot cut across disciplines, even though we are now having agents that are doing that, right? We are using agentic frameworks to do that. So you have to rise above being just a coder or a programmer to being a developer, rise above being just a developer to being an architect, a software architect, right? A software engineer. That's really what that is. So at that level, AI becomes an advantage to you because you can then multiply yourself. AI becomes, your junior, your team members, and you can send them to do stuff for you, right? So anyway, let's keep going. So refactoring prompt, this is a good prompt. Okay, you want it to refactor something. You give it a code sample, refactor. It refactors it to give you the response. Testing prompt. This is, again, for me personally, this is like a big gain for me, right, from AI. Test coverage, unit tests, whatever. I am not even going to stress myself anymore. In fact, last year or early this year, I actually wrote a framework before all of these LLMs came into play so much. I actually wrote a framework that I would basically write a template file for test coverage, because my test coverage was just basically boilerplate code. Boilerplate code is code that is repetitive. The same thing you are just copying and pasting, repeating, just change a few things, right? So for example, I'm writing test coverage. You write test coverage for the it was a backend in Laravel. So you write test coverage for the get, for the post, for the put, for the delete. And it's all the same thing. It's basically the same code, with just what you are changing is the endpoint and the some data and so on. And I actually wrote a template file that had exactly that stuff. I had placeholders. I used what do you call it, Ginger or something, to replace and put the actual stuff. But with this, I don't even need to do all of that anymore, right? I can just tell AI generate code for this. But the difference is that with AI, you still cannot constrain it. So I am now looking at a way I will combine my old way of using templates to generate test coverage with AI that can intelligently add additional context. This is one of the things that we will build as part of this. You will learn how to do that using you can use templates, we can use RAG to improve on the reasoning of the AI so that it uses your templates to generate. Or like we said, AI, you can just give it a format, say, okay, use this format or use this template and generate the test coverage. Okay. So this is something for you as a developer, is a game changer, because it means when you use frameworks like React, you know, um, Express, Nest.js, Next, you know, Flutter, and you are already pulling code out, right? Because you already have the framework. The one that will delay you and drag you so you don't deliver quickly, test coverage. So what do? LLM does it. And you now, like I used to, like I said, for each functionality I wrote, I had gotten to a point where I basically can just generate functionality, right? I had Copilot, but tests will take 90% of the time. I can now reduce it to 50-50. Okay, 50% of the time to write code and 50% to write tests, but the time is now much less. So instead of using maybe 10 days, I'll use 2 days for a particular functionality. So testing is a game changer. Debugging is also a good one, right? If you have errors, you don't know how to find it, or you don't want to give yourself headache, just give it a prompt to ChatGPT, Copilot, anything, and it does that. Documentation prompt, that's another thing. A lot of us are very lazy. We don't like to write documentation, but I've seen a lot of people that I know, including some of the guys that are working for us here. We are having really good documentation generated by AI. So that's another good thing. So you spend more of your time writing the code. Okay, then API generation prompts. So we'll try a bunch of these prompts later on. So there is something I would like us to try as an exercise, right? I want to write, a tool that can look at PRs and summarize and even do reviews. Okay, so, but we'll do it one step at a time first. You have a pull request div, and a div comes in a patch file, so you can do div and forward it into a patch file. Then step one, you ask the LLM to summarize the code changes, then to suggest improvements, then to generate doc strings for the modified function, and then write test cases for new functions, and then produce a markdown summary report. This is a chain. This is a prompt chain, right? Even though we will do it one by one using ChatGPT, because I don't want to start, I don't have a lot of time, so we cannot really be, or Gemini, right? Sorry, not Gemini, Claude. Okay. But one thing you need to understand is that there are multiple ways you can automate this. You can use LangChain, which is designed for automating prompt chains. You can do function calling, basically write your own code and you push each of those in, right? You can use Cursor AI, right? Or you can even do it as a GitHub action in your GitHub workflow. This is the one I'll really like to do. Put in a GitHub workflow. From a GitHub runner, you can actually do API calls. So you do API calls out to the to the AI API, and it chains that. And then you can push that as comments back into the PR. Like I said, Copilot actually does that, but it's for pay subscription. So imagine if you could build your own. I've always wanted to do it, and I'm going to do that. I would say everyone here, try it and see if you can do that. That will speed up your productivity. So, for coding tasks, in summary, okay, number one, use structured input and output, right? Sometimes you can give it examples. So that's where templates are very good. You say, okay, follow this example template when you are generating test coverage. Very good. Keep your context window small so you don't overload the model. If you send the whole repo to the model, it will overload it. So one problem I think we are going to solve, we're going to think about, I would like to hear your thoughts on it is, how do if I ask you to build a CLI that you can use to make modification to your repo, right? How do you solve the problem of a huge repo and the context window? As a developer, build a tool to suggest refactorings in your code base. Can you do that? And I'm going to type that as a problem to think about. Let's think about it. How will you solve the problem of context window? For a huge repo, there are some repos that are big. So how would you solve that problem? So the other thing is include examples of good output style. Okay. Review your AI output for correctness. Don't assume it's flawless. We've already seen the things that can happen, right? There's something we call what's the word, hallucinations, right? So AI tends to do that. That is when they are generating this output. You ask them a question, it's totally out of their domain or what they were trained on, but they're generating with a high confidence because they don't even know they are wrong, right? Treat AI as a collaborator. That's what I've been saying, not a replacement. Don't outsource your creativity, your brain, your technical knowledge, your know-how to an AI. Use it to your advantage. It is a collaborator. Use it as a pair programmer. So don't just go and generate code from AI and submit. I'm actually going to send questions in the next set of tasks. We'll be doing questions that I call they are designed to trick AI. So if you use just AI without using your human brain, you will miss it. So this is very, very important. Okay, so we are now going to go into a bit of hands-on. We have 5 exercises: code generation, documentation, chaining, prompt chaining, debugging, and review simulation. So I would have loved to do this with Copilot or Codium, right, to generate a data validation function. So I might only have enough time to do this first one, but we can try the others. So the first thing I want to do is we will go into the tools. Yes. So yeah, let's look at some of the tools. So we have Copilot, we have Codium, we have Cursor AI. I think I've talked about this already, right? I have Copilot, so but I want to try Codium because it's a free code completion alternative. So the main thing is code completion. You begin to type code and it gives you. It should also have a chat, right? And it should also have a search. So the chat allows you to ask questions. Same thing with Copilot. It has code completion, which means when you start typing, it can suggest entire blocks of code for you. It also generates test coverage, right? And doc strings. Then it also has a chat as well. Cursor is an entire AI native IDE that is built on GPT. So you do need to create an account on Cursor and connect. So you can use Cursor. It's a very powerful tool, or you could just have VS Code with Copilot or Codium. There are a bunch of others, IntelliJ, IDEA, IntelliJ, and so on, that almost every idea, if any idea that doesn't have an AI integration now, is lost forever. So these are the tasks which we will look at, right? for next week. So let me give you a preview, not next week, rather for Friday. Let me give you a preview. So the first one is auto documentation using AI, right? Use AI to generate doc strings and mark down documentation from your code, extract function, class descriptions automatically. These are the kind of prompts you can use to generate doc strings for all functions in this file, right? Summarize this module for developer documentation. And this is a prompt that you can give to the tool, and this is the kind of answer it will give you. So this one is, it gives, you have already written the function, it gives documentation for it. For me, to be honest with you, with everyone on this call, I'm not even so much a fan of all this documentation anymore. Maybe for um, newbies, interns, juniors, and people who are learning, it helps. But for me, I prefer what we call self-documenting code. That's my own, that's my own position, my own stand, right? Use function names that tell what the code is doing. Use variable names that tell what the code is doing. Let your function signature, the parameter list, also have names that, tell what the code is doing. What we call fluent coding. Fluent coding. You write. So once you do all of that, I don't need this code block anymore. Code block for me, is my own opinion. There are things of the past, maybe it's because I've gone so far ahead. It doesn't really matter, but it's good to keep it, right? But for me, it just makes this code verbose, right? Too much information. Calculate discount is a self-documenting function name. Man, this function is calculating the discount. So why do I need this thing, calculate the final price after applying a discount? Unless you want to define what discount is for people. The function has the argument or the parameters price, price, discount rate, I don't need documentation for this, right? That's my stand. But there are some functions that need documentation. If you are doing a complex algorithm, right, then you may want to document, the steps and the things you are doing. But as for this one, calculate, I don't need it. But anyway, for as an exercise for the LLM or the AI, you can try it out. So the other thing is generating test coverage, like we've talked about. So I've also seen a bunch of people do this, which is pretty good, but always review the test coverage. One of the things I noticed with LLM test coverage is very verbose. It's too much stuff. Sometimes you can use parameterization to make your test shorter. Sometimes you can structure the test. Sometimes you can use reusable functions in the test, side of things, in the test library, so that you don't keep rewriting the same thing. Even though you have to be careful how far you go. Don't take it too far, this whole reusability in tests, because a test code is supposed to be self-explanatory. It's supposed to, you should be able to look at the test code and it will tell you what it is testing. Okay, so that's another thing. I believe personally that this whole issue of test coverage is going to be highly, seriously revolutionized with AI, right? There's something we even do currently. You write code, your code base, your test coverage is so huge, your code base is bloated because of test coverage. But I don't need test coverage in a production site. So when I'm deploying, I would even prefer to deploy the code base without the test coverage part of it. Test coverage is good in your repo. It can be big. But if I'm deploying the code to a Kubernetes cluster, each of the pods, I want it to be very small, right? To reduce the size of everything. So these are also interesting problems that I know there'll be changes to how we solve them. So refactoring is another thing. You can simplify complex functions. Like this is a good function that a human being would have written. I see this kind of code a lot. You first of all define the variable. This is also very good for readability. Like, yes, it's easy for me to read. Okay, result is empty string. Then for each D in data, if D is an integer, you append the square of it, right? So this is 1, 2, 3, 4, 5 lines. But I asked AI to to refactor this, and this is what it gives: a single line with comprehension. Of course, if you're a Python developer, you should know that list comprehension does this. D times 2 for D in data, if this instance of this. It's basically the same thing, right? But if you are a newbie in Python, you probably do it this way. For example, if you came from JavaScript, this is how we do it in JavaScript. But in Python, even though in JavaScript you have map now these days, so you just use map, right? So as I always say, all programming languages are converging, so you probably don't need to do this. So anyway, this is another case. Debugging and API generation, right? This is another task that we can do. Then this is the hands-on we will do. Still the same thing, but we'll be using Copilot. This is just me going through some of the additional visual tools that you can download for prompt chaining. So I'm just showing this here so that you can go check out the video again and try out some of these. So you have Langflow, which is a drag and drop visual builder for LangChain. You can use to build LangChain workflows. Flowrise AI is another example. Dust is another example. PromptFlow, this is a Microsoft one, right? LLM Stack, Open Devin, and AutoGen Studio. So this is in addition to the ones that I have done. So I am now going to do a bit of hands-on with the few minutes that we have left. This basically. So let's see. Code generation. I'm going to start a new project with VS Code. Because of the shortness of the time, initially I would have wanted to um, I would have wanted to install Codium, but I'll let you do that as an exercise. Let me just use Copilot and do this. I already have Copilot set up. So I will create a new project with VS Code. All right, so I'll create a new file. So no, I won't create a new file. I will open a new folder just for the purpose of this. Okay. All right. So I already had created this last week. So we have a repo and I have a Jupyter notebook, which we used last week. Now, I'm just going to use Copilot, right? So Copilot has a chat. I'll create a new file. Um, from prompting.py. So you already see the Copilot integration here. When you open a new file that is blank, it gives you this prompt already. Generate code or select a language. Start typing to dismiss or don't sh this again, right? So you could click on this or use the Command I on a Mac or Control I. So let me just click on that. So you see this prompt that comes up and you can basically ask this text box that comes up, you can basically ask any question that you want, any prompt that you want to give. So we will look at the prompts that we have here. So the first one is generate a data validation function. Okay. I'm going to commit the crime of not giving a very good prompt, right? So remember we said it has to be very specific and everything, but I'm not doing that. I'm just, generate. You see, it's actually going to generate a function, but you may not like what it gives you. And that's why it's taking so long, right? So while this is going on, because I don't want to waste so much time, I'm going to give you another example using Claude. You could use anyone. Yeah, so it's even telling me enable access to Claude Sonnet. I do have access to Claude Sonnet here. All right. Okay, so yeah, you can see this has been generated. Validate email, validate phone, validate age. I didn't really give it very good prompting. So let's look at this and analyze this. First of all, my linter is already complaining. 2 blank lines, found 1. Because I'm supposed to put, I'm supposed to follow the PEP. There's a PEP, rather, the PEP, you know, linting rules. I didn't specify that in my prompt, so it didn't bother. It's indenting by single, it didn't bother. Okay. So you could further improve this by saying, generate data validation class with functions to validate emails, phone numbers, um, what else? Um, required fields, dates of birth, and required fields. Write it. How did you know to use Python? Because the name of the file was a .py. Write it in Python, um, and follow the proper code linting and formatting rules. Right. So that's a new prompt. Can you see now? Because I have asked it to follow the prompt, it now has all of this. It still doesn't do I like to indent by 4. Okay. So let's do this again. I should have mentioned, okay, indent by 4. This is one way of doing it. Another way would be the iterative one, which I actually prefer. The iterative approach, I would have accepted what it gave me the first time. Then I'll fine tune it with another prompt. That's a second way of doing it. Okay, so now again, you see, it still didn't indent it as I would have liked. So this is where you see sometimes it doesn't give you exactly what you want. I would accept it. Now I have problems with indentation. Okay, I can use a command I to bring this up. Indent the code in this file by 4 spaces instead of 2. It's still asking Claude. It still fails. So it fails. Now let me take that same prompt. And put it here. I normally use Claude for really advanced stuff. So you see stuff that I'm doing with GPU programming, CUDA and all of that. um generate a validation and input data validation class that validates emails, phone numbers, um, what was the other thing? Dates of birth, required values using Python. Um, follow the proper PEP PEP formatting notation rules. I did not talk about that especially. Okay, so here you can see it actually follows my rules, right? In terms of indentation. So it does generate the code. Okay. Cloud is really good for developers, for coders. This is something that's been said a bunch of times, right? But I've also seen situations where I asked Claude some questions and it really didn't give me a much better answer than ChatGPT and so on. Yeah, but they say Claude is really good for this is PEP 8 compliance, which I asked for space indentation, maximum line length, so all of that. You can then fine tune this by add proper document each function, which was the second thing that we want to do. Generate, so you can say generate a document string, a doc string, generate doc strings and a readme for the code. Now, but what I noticed is that when it's generating the readme, it's going to take off the actual code itself. But yes, you will see the readme as well. So of course, you should have copied the other one. After you're okay with it, copy it and put it where you want to put it. And then you can generate the readme. So, but the interesting thing is I want to do this in my code base, right? There are command line tools that do that. We have one recently that OpenAI released. It's called Codex. Even though I'm hearing that Codex has started going crazy, but it was doing very well before, right? So there is Codex and there are a bunch of other tools. And one of the things I think we here should be able to do at the end of the day is to be able to write our own tools. For you as a developer, that could even be a product. There are a lot of ideas I have. I'm going to share them over time and we'll see how we can build some of those nice products. So, but for you as a developer, yes, this is the way that you can improve yourself. I'm sure most of you are using this already anyway, but I hope this was helpful. Now, when we come back on Friday, we are going to look at prompt chaining in detail. And we are going to use we are going to look at some really complex tasks and see how we can break them down, right? And then use prompt chaining to do them. One of those tasks is I would like to build an AI enhanced PR reviewer or code reviewer that will take code and review it, right? So that's it for today. I hope we enjoyed the class. Thank you.